Solve the equation 2x squared equals 2x plus 4 by graphing. So I'm going to use a technique that's a little different on this problem. What I'm going to do is I'm going to graph the left-hand side of the equation as one function, and then I'll graph the right side as another function, and then we'll see where those function lines intersect. So I'm going to use a graphing technique that's a little different than we've been using so far. What I'm going to do is I'm going to make two functions out of it. The first function is going to be y equals 2x squared, which is the left side of the equation, and then I'll have y equals 2x plus 4. That's the right side of the equation. Then what I'm going to do is I'm going to graph both of these and find points of intersection, and those x values will be solutions to the equation. So y equals 2x squared is going to be a parabola with a vertex at 0, 0, and then go over 1 up 2, over 2, and then up 8. And I'm going to reflect those points. Then we're going to graph y equals 2x plus 4. The y-intercept is 4, or the initial amount is 4. Then the rate of change is 2. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, so on and so forth, and then continue the pattern down this way. Okay, and what I'm looking for here is the points of intersection. And it looks like there's a point here and another point here for the intersection. And this first intersection looks like it's at -1, 2. And the second intersection looks like it's at 2, 8. So the solutions to the equation would be x equals -1 and 2 for this guy up here. When you're solving by graphing, you always want to check your solutions. Now, instead of using algebra to check the solutions, I'm just going to show you the same technique on the calculator. So here we have 2x squared for the first function, and then we have y equals 2x plus 4 for the second function. Okay, let's take a look at the graph. Kind of looks similar. Let me change to a standard window. Okay, now it looks quite similar to the graph that I drew by hand. And I'm going to calculate each intersection. So second calc, and then intersect, which is option 5. Then just hit enter, enter, enter. And there we are, -1, 2, which is exactly what I had. Now we're going to calculate the other intersection, the one up top here. And this time I'm going to move the cursor over close to that other intersection. Enter, enter, enter. And there we have 2, 8, which is good. So my graph by hand was accurate. And you're not always going to get nice integer numbers like this. You could get rational numbers, fractions, repeating decimals. You could get irrational numbers that are long decimals that don't repeat. But in this case, it worked out to nice integer answers. Okay, so our solutions are the x values of those coordinates again. X equals -1 and +2 are the solutions for this equation.